Let's see another popular problem from LeetCode. It's a network delay time. And we understand the problem. And here in this problem, the algorithm we are going to use to solve this is dijkstra algorithm. And dijkstra algorithm is very popular to find the shortest path. So real application is, when uh, when we need to find the shortest path from point one to point two, then we need to do dijkstra algorithm, and that's a very useful. Like if you see some a map in your phone, and you put the source and then you give the destination, and then from the source to destination you want to go there. There are multiple paths from source to destination, and then your app need to figure out which is the shortest path, and where we need to use the dijkstra algorithm. And this problem is exactly same. So let me explain this. It's saying that network delay time. We need to find out network delay time. So here we have the node here, different nodes, and from any node, like in this example, they have chosen this two. K is equal to 2, and there are total 4 nodes. That's n is equal to 4. And from we start from here, and we need to find out the path from here to here, this time taken. So this is like just a one is a time taken, and we can say the weight. So from 2 to 1, uh, this time is taken 1. In order to reach 2 to 3, it's again 1, and 2 to 4, again 2, 1 plus 1, 2. And from this route, we cannot reach here. So we cannot consider. So in this case, from here, this 2 is answered. That means to if you try from this source and try to reach to the destination, so the longest path we need to travel the longest path here, and we need to find the minimum weight or minimum time. So this is the longest path here we see, and the minimum path or minimum the time is 1 plus 1 2. So in this algorithm, when we design this algorithm, dijkstra algorithm, where if you give any path or any source, and we want to know what is the time taken from traverse from this source to this destination, we calculate uh, every age weight. We calculate this path, like we calculate this path also, shortest path from here to here, what is the shortest path, and from here to here, what is the shortest path. We calculate everything and store in an array, and then from there we were going to array, or here in this example I have used map, and then we need to find out what is the maximum time taken, what is the maximum time. So the maximum time is this 112 to reach here. So anyway, that's we say the maximum time, that's the network delay time, but that is the shortest path because there is only one path. If there is a multiple paths, we'll take only the shortest path. So yeah, so that's we need to understand this. So let's see the few example and try to understand how we are implementing dijkstra algorithm, and, and then we'll see the code. So this dijkstra algorithm can be used in many other graph problem also. This is the base. So let's try to understand. In this example, we see 2 1 3 4 2 1, and this is all the directed graph here. From 2 to 3 we can reach, 3 to 4 we can reach, and weight is 1. I just put the same example here. And if you see, the values given like this. There are three parameters here, three parameters here. So the 2 is this node, 1 is destination, and 1 is weight, and this one is weight. Again, if you see the 2, from that's a source, 3 is a destination, and this 1 is weight. And from 3, it's a for destination, and 1 is a weight. So this one we need to put that in a graph. So in a map, what we are going to do, we make this 2 as a key, and in this key 2 is a key, and the value will be this one and this one. So this value will store in an age, like we say that okay, there's an age, and in an age that's a node, and this is a time or weight. So that's why we can store that's in this way, and then we can store that in a graph. So we'll see there in a the graph how we create the graph here. So example, I'll show you the code, but before that, is just try to understand 2 is a key and 3 is a key. So for the 2, I want to store 1 and 1. So 1, and again 3 and 1. So 3 and 1. So this way I'll create the graph. And for 3, again 3 is a key, and the value is 4 1. So 4 is the age, and this is 1 weight. So 4 1. Okay, so in the first step we'll create the graph. In this example, I'll just take this example here, and we can see how we have created the graph. And then step 2, we'll create some lookup, like this lookup. I'm just saying this is the lookup, but this is another map, and this has this has all the node, and all the node like two node, one, two, three, four. You can see all the nodes are here. And for this node, what is the minimum time to reach to reach to the end, that is end, or maximum maximum node here, like from 2 to 4, from 2 to 4. So what is the maximum weight we need, or from 3 to 4, or 2 to 1. So that's we store. But in the beginning, what we do in this time lookup, we just created all the node here, and I just put there's some value I can put there, like some max value. I can just put some max value. This is a max value, some very big value I just put initially. And so that's why in the first step I put this. In the second step, I can say starting from this node. So for this node, I'll just make it 0. This node is 0, and then I'm just writing the algorithm how we are solving this. So once we have a better idea here, step 1 is step 3, and then it will be easy to understand the code again. So okay, so we're starting from here, so that's why I made it 0. Step 2, step 3, create a min heap. So we need to create a data structure called min heap, and in a min heap, we know in a minimum heap, when we store the data, then the smallest value will be at the top, and we'll get the top value there. So in the min heap, and I have also created a few videos on this min heap or max heap. So you can go to my channel, you can search this min heap there, and just you'll find that a lot of video, and you can get the idea on that also. Yeah, so I can just see Nandeshwar LeetCode here, and just go there and the search like min heap. So you'll see some problem on this min heap. Okay, or I mean, this one is the another like easy example. Get the smallest element, and you'll get better understanding on min heap. So you'll get that idea. Okay, anyway, so we create the min heap, and in the min heap I put this value like 1 1. Like for the 2 there's a age, for these 2 there's a age 1 1. So in the beginning I just put 2 0 there, 2, and because if I start from here there is no other age, so just 2, and the 0, the time is 0, because from 2 from 2 to 2 it takes a 0. If you say the second, then 0 second or minute. So that's the weight I just put here, 2 to 0. I put that in a heap. Okay, and then I get, there is a one item, so I get the item from the heap, and when I get the item from the heap, we'll get just 20, and then for the 20 we'll get all the items from the graph. So from the graph for the 2, we have stored this value, we have stored this value. That means 1 1, and this again 3 1. Right here, if you see 1 1 and the 3 1. So we'll get this value one by one. Let's say in a graph loop we get 1 1 3 1. Then we get that, and then we store that 1 1 and 3 1 to the heap. So we get this and put that in a heap. So from the heap, we get on the top item we want to get. So at the top, and based on the shortest item will be at the top. So based on the time, and since both are 1 1, so based on this order, we'll get the 1 1. So 1 1. And for the one key, the graph loop. So we got here graph loop here, and then get 1 1 and 3 1. So for the 1 1, there is, if you get this, there is a no route, so we can just really stop there. So we'll not able to do anything from there. So in this case, then we will get the 3 1. So 3 1 will get, and the 3 1 in the 3, and the weight is 1. So we also see when this weight is 1, then we'll go and we'll check this value for this 3. For 3, we'll see there is a max value, and we'll see the new weight is less than the max value. We update that also. So I updated that also. Again, in the same way, we get the 3 4, and when you get 3 4, we'll get this 1 and 1 2. We calculate, take the old value and calculate and add this, and this is the 2. And then again check, there is a max value, we put that in a 2. So in this way we have all the path here. So if you want to know from 2 what is the maximum value, that is the 4. I mean, that is from 2 to 4, it takes 2 seconds. So that's we can calculate. We'll see another smallest example, and we can jump to the code. So another example here, let's say there is a path here from 1 to 2 to 3, and from 1 to 3 it takes, the weight is 1, so 1 and 1 2, so it takes 2 seconds. Let's say if I put that unit, then it takes 2 seconds, and from 1 to 3 there is another path that takes 4. So we are going to consider this path too, because anyway from this route it takes, even though it has another intermediate node, but this time takes less, and here the time is more in this route. So when you use the dijkstra algorithm will find this smallest path. And again, in the same logic I have put, so I'll just run that and I'll just show you again. So yeah, the code is it's a lengthy, but the logic is again it's a not very much tough. So because if you see this min heap, how to implement the min heap, you can get the better idea if you see the other video, and you can come back and we'll see the min heap. So when we design the heap, we'll design in this way. Like let's say we want to store the age. So first we know the for the key we have the 2 1 3 key, but for the 2 there is a age. So one age, this is one node, and this is a time. So that's why node and time. So from here to here, I just created age. So we can store that value age, the age. And we want to put that in a heap. So that's why I created the array of this age and this length, and swap. That this function is very much a standard function, and the push and the pop is also very standard function there. So in every heap problem, we use this 5 functions, and you can get the better idea in the other video. Okay, so we have the heap here. we have created the main heap, and now we are going to create the graph where I put the key here and the value will be the age. And I am getting the times. So that's if you see on the top here, this is the times. So times is this value. So that's why from the time I'm getting the u, that's a if I start from here u, and then the v, that's the source and destination and the time taken. So these three things I got it. And in a graph key I put the u as a key, and the v time I put that in a age. So age and a node is v and time. So in this way I create the graph. I initialize the heap, and in the heap first I put k0. So that is if you get the 2, I put the 2 0 here. Then create the time lookup, and the time lookup key, and I put some max value. So every key like 1 has a max, 2 has a max, 3 has a max, 4 has a max. I need to update, and I have to check if I get the minimum path, I'll update this. Okay, I will get the one item from heap, and first I get this two item 2 0. So for the 2 0, I'll get the element that is the current age. So I'll get the 2 0 age, and I'll check the current time. Current time is anyway that's a 0. So greater than, it's a greater than time lookup. So for that node, if it is greater than, it's a continue. But zero, this is a 0, and we already put the 0 there. So that's fine here. I'll debug this and we'll see the value, and that makes sense. But let me complete this and then we'll see. And from these two, I'm getting the item from the graph. For these two, I will get this age and I will get this age. And when I get this age, then I'm calculating new time. So new time is uh, the current age. So that is what is the current age time, that is 0, and the age time. So for this age time is 1. And I check that. So if the new time is less than lookup, that's already have some max value. If the new time is, of course, this is less, then the time lookup, I put the new time, and also I push this value to the heap. So in this way, we'll get the value, and finally we'll find, the max value to in order to reach to the node. So from here to it takes max value 1, from 2 to 3 1, but 2 to 4 that's a 2. So just we want to return 2. So let's put that in a debug mode and see how this data is getting prepared. So okay, let me okay, let's put one point here. So in this way we'll see the graph value. So let me run this first. And now we'll see by this time we have already prepared the graph. So the graph 2 is a key, and the 2 node 1 1 and 3 1, if you remember the first example, and we have stored this value. The times is whatever we have passed here this time, so that's value we are getting here, and the k is equal to 2. Now we'll come this lookup. So I'll just put one debug point here, and jump is, now we can see the time lookup, every key has some max value I put. And then we'll come here and we'll see from age lane, we'll get the current age. So this current age, I'll see the current is 2 and 0. So first we got the 2 0 because initially we put the 2 0, and that is the starting point. And we're saying the current current age time. So the current age time is, what is this current age time? So the current age time is greater than this one. So it's not. The current age time is, this is the current age, whatever we got there from the from the heap. So that is the 0. So that's not there. So for the 0, we are getting, for the 0 node, we are getting, all the age. So there are two age from this 2, like 2 to 1, this side, and the right side again 2 to 3, and 3 to 4. So the 2 age we get, and for this age again we calculate the new time. So come here. So the new time in this case, if you see, the new time is 1, because 0 and the first stage is 1. Like if I say this, for this 0, and we traverse here, so, or if we go in this route first, then in this route also it is 1. Okay, because we get first this and also this. So for this one, so that's why I put that here. And new time less than, then we update it. So we'll see the value will be updated here. So if you see, still 3 has a max, 4 has a max, 2 initially put the 0, and the 1 we got, that's got updated, right? For this one we already got updated. Now for the key, this key, we get another item 3. So I can run, and that's get updated, and we'll see the value here. For the 3 also it's a 1. So in a heap also, uh, we have put the data in a heap. So yeah, so this also goes to the heap. So next run, let's put that in a heap. You see the 1 1 and the 3 1. And for this 1 1 again, eh, there is no route from this 1. So description, like from 1 there is no route, so we'll not get anything. So let's see that also. So that's why, there was no route, so it didn't go to this graph, because we didn't have the graph for that. Then from HL, now we'll get, we'll remove this 3 now. Okay, now remove the 3. And for the 3 there is a age, so that's why the new time, it will be now 2. New time will be 2, because for this age we calculated this one plus this one, and that becomes 2. And then again we updated that in a lookup. So to 4 is 2, and this is the lookup tuple. This is important, like from 1 it takes 1, uh, from the 2, the path is the max value is, we can just see the max value is a 2 here, so we need to return this 2. So we'll calculate that, and we'll come out to this place. We are here, and in the time lookup we're just checking if there is a max int, if there any max int value is there. So that means if you cannot reach, then return -1. Otherwise, if you see, the p greater than result, so we need to find out some max value here. So for this 2 is the max value, so we calculate this and we can return that. So that's the logic here. Yeah, you have to see this thing by yourself. I can just show you the Java code also. We have to use the priority queue in a Java, but we have used exactly same logic, age, the hash map. We have used the priority queue. that's all good. So that's all for now. Thank you.